Welcome students. Now we are going to start this topic dimensions of physical quantities, dimensional analysis and its application. So all these three topics we are covered in this video. Let's begin with the first topic, symbol for dimensions of fundamental quantities. So firstly, what we are going to do, as we know from the previous knowledge, we have a 7 fundamental quantities. And from 7, we are using the 3 absolute quantities, which is mass, length, and time. So how we represent or how we symbolize that particular quantities into the like symbol for the dimension. Length L, mass M, and time T. Temperature K or theta, current I or A. So these three are we are saying as a absolute quantities. These three. Absolute. Absolute quantity. So in the class 11, generally we are using L, M and T. And in few standard quantities, if I'm just taking the class 10th, class 12th and with the 11th also, but these are very less used. Okay. Mostly use the absolute quantities. We are saying this is a normal, like temperature, we are using K or theta both. Current I or A both. It's up to you students, whatever you want to write. But during the representation, like if you want to represent the temperature like ml to T minus 2 like this and theta minus 1. So for that, you just little bit representation, give the representation what m is a length, what m is a mass, what l is a length. Okay, little bit representation, you have to just break it down. How will we just give the dimensions? I'll just brief later. So what is a dimension? It is the power of the fundamental units of 1 unit of the derived physical quantities. Like if I'm just taking a particular derived quantities, for example, force. So for representing that derived physical quantities, we need some units. And again, what is the derived physical quantities? Which is come from the fundamental quantities. So fundamental quantity there have own units. So if we represent that derived quantities or the derived particular units, so again we need a particular thing for the fundamental units. Let's begin to more elaboration. Like luminous intensity, we are just taking CD, amount of substance mole, but we are not using these particular things. Dimensional formula, like how to represent that particular thing in a dimensional term. It is the expression of one unit is derived physical quantities. So dimensional formula of a physical quantity is the P is like P is equals to M X L Y T Z. We are not saying M to the power X, L to the power Y or T to the power Z. We are not saying like this. Mx Ly Tz or m minus 1 L2 T minus T. It's up to you. Like whatever the value of x is given 1, 2, 3. Accordingly, we just pronunciate. But what is the correct pronunciation? Mx Ly Tz. So where x, y, and z are the dimensions of fundamental quantities of m, l, and t respectively. How do you determine the dimension of speed? So step 1. We are just taking step-by-step process for a more elaboration. Clear students, so that you are understand the process in a very smooth way. So speed is equals to what we know, distance upon time. Good. And then the next step is what? What we are going to do? Speed is equals to, we just write the dimensions. So as we know students, the distance unit is a meter. And in the dimension, meter is of what particular unit quantity? Length, yes. So actually what is the distance? It is a length. And we are just written dimensional formula as an time, t. Okay. So instead of writing this, because we are just taking absolute quantities. So here m is not present over there. That's why we written m0, L1 or T0. Instead of L1, if you don't want to write L1, so you can eliminate that part. You can choose this one, M0, L, T0 also. So you both have like method to write this particular steps. So I think you understand how I represented that one. Similarly, again we will go through the absolute particular term. So we use MLT, three terms. As we know, the time dimension is T, that's why I put T1. So this much have you understood, students? I hope so. So step third, we just little bit solve it down and get the result. So again, M is a completely cancel out with each other. That's why we just taken M, L and T minus 1 because this is the downside. Okay, this is in the denominator part. When we raising in the numerator part, that will become T minus 1. I hope this will be understood. So you got it, my point? Now, determine the dimensional formula for temperature gradient. So, firstly, we know the formula. Understood? Before starting to determine the dimension, you need the formula. That's why you have know each and every formula which is given, I think page number 281 in the NCERT booklet now. So you can just open, you can prepare that formula or by the practice you can do. Now what you have to represent, just write down the temperature. So we are not forgetting the absolute terms. Students, please remember, you are not forgetting the absolute terms, which is MLT. Okay. So here, as you know, the temperature unit is a K, but here not length, mass, and time is not given actually. So that's why we just putting M0, L0, T0, K1. Clear? And the distance, I hope you are able to give the answer. This will be yes. M0, L1, T0, K0. Now student, why I'll just put K over there. The reason is behind upside term is a K present over there. So downside term, if we just want to calculate the properly term, that's why I put the K over there. Okay, downside term like a denominator term. The step 3, to solve that particular term. Okay, so what we did? M0, L minus 1, T0 and K1. I hope you understand, student, the process how I solved. Dimensional equations. When a physical quantity is equated with dimensional formula of the same physical quantity, then it is called dimensional equation. It is a principle of homogeneity of dimensional formula. For example, consider V. So we know that V is equals to what? V is equals to U plus AT from the first equation of motion. If I just want to find the dimensional formula or dimensional equation for that, so velocity LT minus 1 with the M0 because this is the absolute term. M0 LT minus 1 because this is the again initial velocity, the dimension will be same. A M0 LT minus 2 and T M0 L0 T minus 1. For more elaboration, student, I'll just want to give a little bit brief what is acceleration. Acceleration is nothing but the velocity by time, and velocity is what? Length by time. So if I just want to write the dimension of a length, this comes M0 L T0. Again you can write 1 also. Time M0 L0 T2. Clear? Now M0, as you can see, this will be again cancel out. So M0 L0, if this will become upside, so again L1, okay, and then T0 minus 2. What the answer come? M0 LT minus 2 over there. So that's why we just put it over there, M0 LT minus 2. I hope you understand, student. This is a little bit equation. Now dimensions, I hope you understand how I just put it this values continuously. V is a what? Velocity. Again, this velocity is the final velocity. This is the initial velocity. A is acceleration here, t is the time. Physical quantities on the basis of dimensions. Dimensional variable first has a dimension. If I'm just taking a dimensional variables that have a dimension, does not have a fixed value. For example, force, velocity, acceleration, these are dimensional variable. Force continuously can change, velocity also changing, acceleration also changing. So these are the variable terms, not a constant terms. Okay, so variable terms have a dimension, does not have a fixed values always. So dimensionless variable. For example, dimensionless variable has a no dimensions. Does not have a fixed value. Again, if I'm just taking a dimensionless variable, which actually in the name says a clear, which don't have any dimensions. Clear? So that type of a thing have a not fixed value also. For example, refractive index, plane angle. Why we are taking that this value not fixed? Actually, if I'm just taking the formula of refractive index, this will be C by V as you remember. C is a what? Velocity. Again, unit is a meter per second. And this is a meter per second also. So they don't have any particular dimension because they don't, I'm not saying this don't have a unit, I'm just saying this don't have a dimensions. Understood? So because a plane angle have a unit that is a radian, but they don't have a dimension, they both things are different. So please keep in mind, student, like c m0 l t minus 1, this is a unit of a c for a both. That's why again, if I just want to write the dimension formula for this, so this will be m0 l0 t0. Clear? After the division part, no value scheme, that means no dimension. Clear? And the same similar in the case of a plane angle. What is the mean of an angle? This is an arc by radius. Arc is actually a length, and again radius is a part of a length. Again m0 l0 t0 gains. Clear? So they don't have any dimensions, but they have unit. Okay, I'm not saying they don't have, may or may not be. They may or may not be have a unit, but they don't have any dimensionals formula or dimensions. Understood, student? Four categories of physical quantities we make in. So dimensional constant has a dimension, has a fixed value. For example, gravitational constant, always same, gas constant, Planck constant. These always have a constant values and have dimensions also. Like one example I can take with the gravitational constant. So we know that gravitational constant formula G is equals to Fr square by M1 M2. Dimensional formula for force is M LT minus 2. R is a part of a radius, that means length. Mass, this will be m2. We can write over that like m2 l0 t0, and similarly with this like m0 l2 t0, we can write over there for this also. So after a little bit solution, what we get, as you can see, 1 is over there, and when this 2 raising upward direction, like if I'm just want to move in the numerator part, what will become m minus 1. L1 is there, L2 is there, like 1 plus 1, 2, this will becomes 3. T minus 2, okay, and less of the part is a 0, so M T minus 2. So what is the final conclusion? M minus 1, L3, T minus 2, and they have a fixed value also, like 6.67 10 to the power minus 11 Newton meter square per kg square. They have a fixed value with the fixed, okay, dimension. Dimensionless constant has a no dimension and has a fixed value. For example, constant number like 1 and 2, they don't have any actually dimension, but they have a fixed value. Now let's move with the some questionnaire part so that we can revise the things which we like recently covered. Unitless quantities always have a number. may be a physical constant without dimensions, has no dimensions. All the above are correct. The correct answer is a unitless quantity is always a number, may be a physical constant without dimension and has no dimension. Which of the following is a not dimensionless quantity? Angle, strain, specific gravity, or density? Not dimensionless means they have a dimension. Angle, we know. Strain means the formula of a strain, change in length upon original length. Angle, arc by radius. Now, I'm just dropping the things to you. So the correct answer for this question is the density, because density have particular unit. This is a mass per unit volume. Mass means m and volume L3. So this is a ml minus 3 T0. This is a particular dimension for this quantity. Specific gravity also. Next, if the dimensional formula for a physical quantity is ml to T minus 3, T minus 2, then physical quantity is torque, impulse, force per unit area. So for that, students, if this question came like that, what you have to do, you just calculate, start to calculate. So first we will just take the value for torque. Torque is the force into displacement, and the unit of force is mlt minus 2, and the displacement is again a part of a length. So m0 lt 0. If we just solve ml2 t minus 2, again this is the same. So by the first particular option, we get the answer. This is a torque. Okay, I hope you understand. Next topic we have physical quantities having same dimensional formulas. So here we are just going to discuss the some physical quantities which have a same formula, like distance, displacement, radius, light year, wavelength, radius of a gyration. All these terms have a one single formula, which is the L only. Please keep in mind this all the parts of a length. For a particular this question, I just want to give a quick trick to you. Distance, length, displacement, length, radius part of a length, light year. You may confused for this, so please memorize. Light year is a distance actually. Wavelength. In this you can got the particular term length. Radius again, as I told you, is a part of a length. Speed, velocity, and velocity of a light. Lt minus 1. Acceleration due to gravity, intensity of a gravitational field, centripetal acceleration. This is a Lt minus 2. Impulse, change in momentum, mlt minus 1. Force, weight, tension, thrust, mlt minus 2. Work, energy, momentum, moment of force, that is a torque, or a moment of a couple. Again, ml2 t minus 2. Force constant, surface tension, spring constant, energy per unit area, mt minus 2. Angular momentum, angular impulse, Planck constant, ml2 t minus 1. Angular velocity, frequency, velocity gradient, decay constant, rate of disintegration, t minus 1. Stress, pressure, modulus of elasticity, ml minus 1 t minus 2. Angular momentum and Planck constant have the same dimensional formula, ml2 t minus 1. Electric field and potential gradient have the same dimensional formula, mlt minus 3 a minus 1. Surface tension, surface energy, force gradient, and spring constant have the same formula, ml0 t minus 2. Acceleration and gravitational field intensity have the same dimensional formula, m0 lt minus 2. Force, weight, and energy gradient have the same dimensions, mlt minus 2. Light year, wavelength, and radius of a gyration have the same formula, only L, that is m0 lt0. Now, we just look like recently that few dimensional formulas. So we are moving ahead with the question. Which physical quantity is similar to dielectric constant according to the dimensional analysis? Stress, strain, electric capacity, electric permittivity. The correct answer for this question is strain, because this is a constant, and if I'm just taking a constant, so they don't have any dimensions, and we know a strain have a no dimension, that's why we're taking this. The product of energy and moment of inertia is the dimension as same as the square of the linear momentum, the square of the angular momentum, angular impulse, Planck constant. The correct answer for this question is, students, the square of the angular moment. Principle of homogeneity. So homo means same. Okay. So please, the things like that which have a same dimension. Okay. So principle of homogeneity. It states that only quantities have a same dimension can be added, can be subtracted and equated. Clear? Means if this like quantity have a same dimension, then we only can add and subtract, or somewhere if we want to equate that value, so we can equate if they have the same dimensions. For example, x is equals to y plus z. So x have the same dimension, y and z have the same dimensionally, they are equal. Again, dimensionally they are must be equal. Use of a dimensional analysis method to check the correctness of the given equation. This is based on the principle of homogeneity. To convert one system of a unit to another system of unit. To derive the equation showing the relation between different physical quantities. Limitations of physical or dimensional analysis method. Dimensionless quantities cannot be determined by this method. Constant of proportionality cannot be determined by this method. They can be found either by experiment or by theory. This method is not applicable to derive trigonometric, logarithmic, and exponential function. So these are the limitations. For that, we just move further. In the case of physical quantities, which depends on more than three physical quantities, this method is again not apply for that, because it's too difficult to obtain physical equation. The proportionality constant cannot be obtained from this method. If either side of equation contains addition or subtraction of physical quantities, we cannot use this method to obtain physical equation. Applications of a dimensional analysis. So generally we have a 5 dimensions or 5 applications for that. One by one we study. Okay, now but right now in our syllabus only 3. First, to convert a physical quantity from one system of a unit to another. The magnitude of physical quantity remains the same whatever may be the system of a unit is. For example, like first, N1U1 is equals to N2U2. Dimensional formula of the quantity Q B M A L B T C. Clear? So this is the first unit which we are just like want to represent over there, and M1 to the power A. So how we represent this? Simply we just put this value M1A, L1B and T1C equals to N2, M2A, L2B and T2C. Clear? Next, N2 is equals to N1. That we can write M1 by N2A, L1 by L2B, T1 by T2C. Now convert 1 joule into work. So earlier we saw this formula. This is the main formula to get or convert one system to any other system. This is the main formula. This is the question which we are taking here. Like convert 1 joule into erg. So quantity which is energy. Joule is the actually unit of energy. And we can say also work also. So work is a form of energy. We are just taking over there. The dimensional formula for energy is ml to t minus 2. So as you know, as you can get over there, the value of A is 1, B 2 and C minus 2. Clear? So SI, this is a CGS. SI, M1 1 kg is 1000 gram, L1 1 meter, 100 centimeter, and N1 1 joule is present over there. Instead of a CGS, M2 1 gram, L2 is equals to 1 centimeter, T2 is equals to 1 second, and N2 is equals to again the question mark. So we just put all these terms over there, like N2 is equals to what? N2 is equals to N1, 1000 by 1 power 1, 100 power 1 by 1, and 1 by 1 to the power minus 2. Little bit solution here we need, and we got the final result, which is a 1 joule is equals to 10 to the power 7 erg. I hope students you understand. Next, second, to check the correctness of a given physical equation. S is equals to ut plus half at square. Dimensions of different terms are S is equals to L, ut is equals to LT minus 1 T, and here L. What we just put half at square. If I just take in this dimension, again L. As all the terms on the both side equation have the same dimensions, so the given equation is dimensionally correct. To derive the relationship between the different physical quantities, like the time period of oscillation of a simple pendulum depends on a few physical quantities. This is the most important terms, most important. Okay, what we studied till now, this is a really most important term for the examination purpose. The period of oscillation of a simple pendulum depends on the few particular things, like a mass of the bob, length L of the pendulum, and acceleration due to gravity G at a place. So we have to derive the expression for its time period using method of dimensions. Like T is directly proportional to m to the power A, L to the power B, G to the power C. If you are speaking like this, that means you are not doing correct pronunciation. Okay, so how we just do? T directly proportional to M, A, L, B, G, C. Again, T is equals to MALBGC. This is the first equation. K is the dimensionless constant. So substituting all the dimensions of the various quantities in this equation. M. M is a mass. Again, capital M over A. L over A over B. And G, again, this is the acceleration due to gravity, LT minus 2 over C. T is a time period. Again, M0, L0, T1. So M0, L0, T1 is equals to M, A, L, B plus C, T minus 2C. Equating the exponent of MLT on both sides, we get A0, A की value 0 यहाँ पर है, B plus C is equals to 0, minus 2C is equals to 1. We got this value simply. A is equals to 0, B is equals to half, C is equals to minus half. So T is equals to K M0 L half T minus G minus half. We just put this value and got the term K under root L by G. From experiment, we got this value of a K, which is a 2 pi. So finally, what we get? T is equals to 2 pi under root L by G. Now we just move on the few questions so that we just understand more terms. Dimensional analysis method can be used to check the correctness of the given equation, to convert one system of unit to another system, to derive the equation, all of the above. What was the correct answer? The correct answer is all the above. The quantities which are added or subtracted or equated in the physical equation should have the same dimension. This is known as principle of homogeneity, law of gravitation, law of conservation of momentum, and law of linear momentum. The correct answer for this principle of homogeneity. So students, I hope you understand this complete chapter and especially this part of a dimension, which is the most important term. So thank you for watching this video. Be joined with this Nagin group of Institute of Digital Learning and School. Take care everyone.